This is one more chance to get some practice with law of sines and cosines. I think it's important that you pause the video to try each step on your own first. Make sure you do all the calculations on your own calculator so that you are confident for test day that you are doing the problems correctly. So let's jump right in here. And I think whether you draw the triangle or whether you have a visual or an imaginary picture of this, I always put if I'm given one angle, put it in the lower left just because I read from left to right seems most obvious to me. So I'm not exactly sure where to put angle B yet, but I know I'm given side B is across from it and side A is across from side B. And then I quickly see that this is our side angle case, so it's the ambiguous case. Is the 6 long enough? That would give us no triangles if it is not, and we will know that very quickly because we have a pair of angle and side opposite from each other. So our first step would be to try and find angle B. So to find angle B, I'm going to set up law of sine. Anytime you have a capital letter and a small letter that pair up, you're going to choose law of sines. And we've got a 9 here. And I like having my variable in the numerator because all I have to do is multiply 9 on each side. And then I'm ready to go to my calculator. Make sure your calculator is in degree mode, not radians. And I'll pause the video here to check out what you come up with. And I come up with something like 0.9939 for the sine of angle B. And we don't need that angle symbol anymore. That's from your geometry days. And let me go to our calculator model here and remind you that once you have that value into your calculator, to do the inverse sine, if you hit the second key and then the sine button, and then if I already have that value, and here it was 2 steps ago, so I use the up arrow until I get it highlighted. So that's quicker than having to retype it. So if I just use the up arrow to highlight it, hit the enter key, and it will pop it right into my new line there. And I close the parenthesis, and there's our angle B, 83.7. All right, so there is an angle B. Now what you have to say to yourself is that is probably not the only angle B. That perhaps has a matching value. So now we know that B works. This side 6 reaches. So I'm going to call this angle now B1. And we just came up with 83.7. And here's our situation where I said, think of this side as if it were a string. Can you take that string and swing it around like a pendulum to come up with an isosceles triangle? So these two sides could both be 6s. And if this angle is 83.7, then so is this angle 83.7. So now there is an angle B2. So let me use a green stylus. Oops, I guess, is that green? I guess it is. So this is going to be our second triangle. So now we can find angle B2. That's going to be our step 2. Angle B2 is the supplement of angle B1 because these two angles are both 83.7s. So I take the supplement of this angle, and it looks like we'll get 96.3. You can use your calculator, of course. So now I think what would be helpful for us is if we saw both of these triangles so we kept track of where we are. So we have this triangle A is always 41.5. We just found out what B2 is. It is 96.3. Let me get it out of the way there. That's not going to be a good spot. This angle is 96.3. And our sides that were given were 9 feet, 6 feet. So this is going to be what I have left to do. Angle C2 and side C2. And then I'm going to use the same space here to draw that red triangle. And that one still has the same angle A of 41.5. It still has side B of 9 feet. It still has side A of 6 feet. This was the angle we called B1. So now we have to find this angle C1 and this side C1. So we've got a couple of things that we still have to find. All right, so we're really just done with step 1 and step 2, and it would help me out a lot when I grade your paper if you circle your final answers here. So there's my B2 angle, and here's my B1. All right, so what can we find very easily? Well, now we can know 2 angles of the triangle. So couldn't we simply subtract from 180? So step 3, in my red triangle, I can find angle C1. That's a capital C1 by taking 180 minus the 2 angles that we already have found. And in the green triangle, for our step 4, we could do the same thing. Keep that green stylus. We can find angle C2 by doing the same exact thing. Subtract the angle we know, and the one that we just found was 96.3. And let's stop and calculate both of those. All right, and this is the point at which we have actually confirmed that both triangles work, because there was still room for an angle C2. If our 2 angles had already added up, if these 2 angles that I just underlined were already more than 180, then there would be no second triangle. So, all right, what's left to do then? In our red triangle, so our step 5, we have to find small letter C1, and that's going to be a law of sine again. And we're going to go right back to what was given. So we knew that side A was 6 and angle A was 41.5. And now we're looking for C1. So do you see that I turned the law of sines upside down? The only advantage of doing that is so that my variable is in the numerator. You don't have to do that, but now I can calculate this very easily. Just multiply that term to the other side. And I'm going to save a space here for my answer for C1. And I'm going to set up in my step 6, the last thing I have to do. I have to find small letter C2, and I do it exactly the same way. To find C2, I use the same side A and angle A are in both of these triangles. And here I'm going to be finding C2. And remember that angle C2 is something different. It is 42.2. But again, you don't even have to show the step where you're going to multiply this to the other side. And that's going to give us our answer for C2. So again, you can pause and calculate, see if we agree. You can always check my calculations if I make a mistake. You can certainly correct those. But remember that when you're finding a distance that you should label it with correct units here. I think it was feet. Yes. All right. Our next triangle to solve, to keep this moving quickly, I kept angle A as 41.5. And here we kept B as 9 feet. And now I hope you're suspicious here that I was trying to point out what happens if there's no such triangle. So do you think that 5 might be too short to reach? So your intuition is going to save you a lot of points in these problems. So again, we know that A, small letter A and capital letter A pair up, and we can try to find angle B, and we'll find out whether it's possible or not. So sine of angle A over side A, sine of angle B over side B. We multiply the 9 to the other side, and if we get a value that is bigger than 1, we know that that's impossible. The sine of an angle is never larger than 1. So grab your calculator and see what you come up with. And I come up with something close to 1.193. So immediately we know that's impossible. So we like this problem. There is no such triangle, and we are ready to move on to the next problem. So if you'd circle that for me, make sure that you don't just guess at that. Make sure that you show me the work that justifies that. All right, and then let's try another set of information here. We still have that same 41.5. That was a little too shallow. Let's try it again. 41.5 degree angle for A, and we still kept B as 9 feet. And now notice the big difference here is there's no question whether it works. A is greater than B. So A is going to swing way over here. I'm sorry, letter B. This side is going to swing way out here, this side A. And again, you can think of it, well, if that were a string and you swung it like a circle, it would land way over here outside the triangle. So that's why there's only one triangle when the opposite side is longer. So here we would just simply go through our steps of doing law of sine first to find angle B. So set up a proportion to find angle B. That would be your step 1. And then your step 2, once we know two angles, then we can find angle C by taking 180 minus angle A minus angle B. And then our step 3 is to do one more law of sines. So we have to do law of sines twice. In step 1, law of sines. And in step 3, law of sines to find side C, the small letter C. All right, but I think you can finish that one up. Question 4. Now we're switching to a new set of data here. We've got an angle that is obtuse, so a little bit less confusing. So if angle A is obtuse, then either it's going to work or it is not going to work. So here our side B is still that 9 feet, and our side A is too short. Could we have, if we have an obtuse angle, that's going to be the biggest angle in the triangle? Remember that across from the biggest angle has to be the longest side. So clearly this 6 is not going to do it. It's not going to reach to make a triangle. So here's another case, no such triangle. So remember that if you have angle A is the largest angle, then side A has to be the longest side. All right, so let's see what we've got in number 5. Here we've got a side, side, side case. So now we cannot do law of sines. So in a side, side, side case, we could find any of the angles, but we have to use the law of cosines to do that. And in law of sines, if you have a choice, you should find the smallest angle first. For law of cosines, when you have a choice, you should find the largest angle first. And the reason for that is because you can have an angle that has a negative cosine. If it is an obtuse angle more than 90 degrees, think of the unit circle. When an angle is more than 90 degrees, then its cosine will be negative. So find our longest side here is B. So we're going to, in step 1, we're going to find the largest angle, and that would be angle B. So we're going to set this up using this version of the law of cosines. And I suggest that you do a little preliminary work before you go to your calculator. We are going to try to solve it for this cosine of b. So I'm going to subtract these two terms to the other side. And you've seen this enough now that I think you should be able to do this in one step. And then can we divide by this coefficient of cosine? So you can do that in two separate steps if you wish, but I think it's worth being able to very quickly rearrange that law of cosines. So now we can plug in the values that we know here. So we'll have 9.1 squared minus 7.3 squared minus, oops, did I write the same thing twice? I think this would be a problem. You'll catch your mistake, I guess, if you do that. Sorry, these should have been C's. Those two should have been C's. So let's get this fixed up here. Sorry about that. All right, so we can't use the same one twice. So, all right, so now we have our b squared minus a squared minus c squared. And now what do I have up here in my given? A, B, C. So I'm messing this problem up completely here. So what do we want to do to fix this? I'll fix it on your worksheet to match this. So let's call this B, and let's leave this, no, let's call this one C. Sorry guys. Fixing my typing mistake while I make the video. All right. Let's go with this order. All right, so 9.1 for b, so I don't have to redo it. Minus a squared minus c squared. That's our quickest bet to fix it up. All over negative 2 times a times c. So you can calculate this, and remember order of operations to put your numerator in parentheses in your calculator and your denominator in parentheses. That's, you don't have square brackets, put them in parentheses. And the same thing would be true if you get a number that is bigger than 1. That wouldn't work, but it is okay for this cosine to be negative if it turns out to be an obtuse angle. So then once you compute the left-hand side, if it works, then you're going to do the inverse cosine. So you can pause and calculate this one. All right, you can check my calculations here, but I did get a negative value for the cosine, and then I used the inverse sine. This should still say cosine of b here. And then I used inverse sine. So it is okay here if it's between -1 and +1. So the cosine is negative simply tells me that we're in quadrant 2. So we have an obtuse angle B. Nothing wrong with that. So now we're only done with step 1, but we can finish up much more quickly because now we can switch to law of sines. So now we can find either of the other two angles. And when you're using law of sines, our idea was to always pick the smallest angle first. So now that I know small letter b and capital letter B, I think I will find angle C. So I think I will use the sine of angle C in my second part of my law of sines. And I will use the b's that we just came up with here. So the sine of 109.8 over side B, 9.1. And I think now you know how to solve that. And then remember what step 3 is. Step 3, once we know angle B and angle C, then it would be easy to find angle A. We simply have to take 180 minus the two angles we've already found. So that's going to give you your angle A. And then if you would remember, please, before you move on, to circle your answers so I can find that you've done all 3 parts of the triangle. All right, in question number 6, now we have 2 angles, A and B, and we have a side C. So it looks like we can't do law of sines because we don't have a small letter that pairs up with a capital letter. But don't be deceived. If you know two angles of a triangle, then don't you know the third angle as well? So by a very quick subtraction, you actually, if you're given two angles, that's the same thing as giving you all three angles. So our angle C is 52 degrees, and now we are free to use law of sines. So now let's think about it, and you might want to say at this point, do we believe this triangle is possible? Well, it's not a side-side angle case, so there's no ambiguity here. I don't think we have to worry about this. You could draw the triangle to convince yourself with a 42 degree, a 52 degree, and an 86 degree angle. So however you wanted to draw that, maybe something like this. That angle 86 might look a little too large here. This is our angle B, that's our angle A, that's our C, and we know side C is 9. So now you can see that you can pick up and find another side, and let's do A. So you could do 9 over sine of C is equal to small letter a over sine of A. And then once you know that, then of course you could repeat the same process, and you don't even have to change much in your calculator. You can just type over the top. Now we're going to find small letter b and use sine of b. So I'm leaving these for you to calculate. I think you guys are capable of that. All right, and then our two area formulas. If we are given the three sides, then we're going to use Heron's formula. And Heron's formula is first going to require the semi-perimeter. And the semi-perimeter is half of the perimeter. So we're going to take, to find S, we are going to take 9 plus 8 plus 7 and divide by 2. And that looks like 12. If the calculations aren't easy, then you're going to grab your calculator anyway. So just go ahead and do that. And then we have 4 numbers under our radical here. So you leave the semi-perimeter all by itself, and then you take the semi-perimeter minus each of the 3 sides. So there's going to be 4 numbers under your radical. So 12 all by itself, and then 12 minus 9, and 12 minus 8, and 12 minus 7. And you could, of course, do some of that arithmetic more quickly by hand. That's a 3, a 4, and a 5. And you can grab your calculator and round this off. Remember, this, by the way, might be better if I didn't put just that A. That might look like an angle, so you might want to put area here so that you remember what we're finding is an area. And if I calculated that correctly, I get 26.8. And if I knew the units, so by the way, if it said inches here, then you would label your answer in square inches. It didn't tell me any units, so I'm not obligated to label it. But you might, just for sake of clarity, put the generic word units squared. All right, and one more area formula, and that's for our side angle side case. And that used the sine formula. So the area is equal to 1/2 of A times B times sine of the angle between them. Do you see that angle C fits right between sides A and B? So once you know these formulas, there's nothing to it here. Grab your calculator to do the work. Round your answers to the nearest tenth unless you're told otherwise in the problem. And I come up with an area of approximately 34.4. And again, I don't know the units, so I'll just put this. All right. Hopefully that will help you to prepare for our chapter test.